Hello, this is G. Om Kedareshwar Kiran from Electrical and Electronics Engineering Department at IARE. The topic today is about non-blocking DRAM refresh. Let us go depth into the topic. Non-blocking DRAM refresh transformation memory access. Welcome to this presentation on non-blocking DRAM refresh. Today we will explore how this technology addressing the challenges of traditional DRAM refresh operation, improving memory access speed and efficiency. Prepare to delve into the core concept, implementation details, and the potential impact on future computing systems. This digital circuit DRAM transform memory access through the different types where the DRAM operations, memory access, speed and efficiency prepare to implementation of the potential impact of future computing systems. Now going into the challenge DRAM refresh bottlenecks in the modern system. Modern computing demands rapid data access, relying heavily on dynamic random access memory. Dynamic random access memory is DRAM. However, the inherent nature of DRAM requires period refresh operation to maintain data integrity, leading to potential bottlenecks. These refresh cycles necessary to prevent data loss can significantly impede system performance, particularly during high-intensity tasks like gaming and or data-intensive application. This performance plentifully is especially pronounced as DRAM technology scales to larger future sizes and higher operation frequencies. These are the DRAM different bottlenecks in the modern system, and computing demands rapid data access, relying higher random access memory. However, the inherent nature of DRAM requires period refreshing operations and maintain the data integrity with the potential bottlenecks. This cycle refreshes the necessary prevent data loss can significantly impede the system performance. Now, understanding traditional DRAM refresh operation. In traditional DRAM, each memory cell requires periodic refresh of operation to maintain its storage data. This involves reading the cell connect, amplifies the signal, and rewriting the data back into the cell. These operations can occur in synchronous manner, synchronous with the same type, same speed, where the memory control pause all the different significant performance penalties, particular or application requiring high data through output. Alternative refresh. The refresh can occur asynchronously through spreads between the memory axes. The approach reduces performance impact but introduced complexities in memory controller design and scheduling. These refresh rates occur asynchronously between the memory axes. The approach reduces performance impact, but the memory controller design is scheduling highly for the operation of traditional DRAM refresh operations. Understanding its refresh rate and significant performance with these penalties, particularly application in higher data through output. The synchronous means it is with the same speed, and asynchronous with the same inspired between the memory accesses between these four types. Now coming to introducing new non-blocking refresh core concepts. Non-blocking DRAM is a innovative approach that aims to eliminate refresh rate bottlenecks and separating refresh operations from data access. This allows the memory control to continue processing memory requests without interruption even during refresh cycles. The core concept involves dividing the DRAM array into multiple banks, and each bank responsible for refreshing its own set of memory cells. This allows refresh operation to occur currently with the data access in the on the banks, minimizing performance impact by enabling parallel refresh and data access. Non-blocking DRAM refresh through removes the bottleneck and the traditional DRAM refresh cycle, introduce paving way of faster and more efficient system. Now coming to read Solomon codes of data recovery, there are three types. A key aspect of non-blocking DRAM refresh is used to error correction codes, especially read Solomon codes and ensure that the data integrity these codes and reduced the data allowing for the error reduction of correction and refresh operations. When a cell is refreshed, the data is encoded using the random codes and adding extra bits. It can detect the correct errors of might occurring during the refresh process. This ensures that the data remains accurate and reliable despite with the encountering refresh operations. Reading some Sullivan codes powerful Solomon codes powerful tool of data recovery as the code correct multiple errors within a block of data. This redundancy essential for non-blocking DRAM refresh as it allows the memory system of operate efficiently and reliable even with encountered refresh cycles. So these are the different types of DRAM refresh. It allows the memory access and also the data codes of recovery of different things, where the key aspects of non-blocking DRAM refresh rate is used for read codes and extra bits of detect the device storage. Now coming to the hardware implementation and system requirements. Implementing new DRAM refresh requires careful design and considerations at the hardware level. It involves modifications to the RAM controller and memory architect to enabling concurrent refresh and data access. So the DRAM controller need to design to manage the refresh cycles occur different banks, ensuring that all banks are refreshed in a timely manner without interrupting data access. The involves sophisticated scheduling algorithms and coordination between the controller and the DRAM. System requirements include support for read codes in the memory controller and the use of DRAM chips and the support bank level refresh operation. These modifications are essential to ensure that the system can efficiently leverage the benefits of non-blocking DRAM refresh. So these are the three types of hardware implementation where the system requirements need implementation DRAM control system requirements. Now coming to the performance and benefits for DRAM and SRAM like behavior. 15% of latency reduction latency of memory access by eliminating pulse for refresh operations. 20% through output improvement, increases throughout by enabling simultaneous data access and refresh percentage. It is 20% and 50% of reduction latency. 50% energy efficiency reduces energy consumption by eliminating unnecessary refresh rate operations. Yes, the refresh rate is about more than 120 hertz. Then it is eliminated the 50% of energy efficiency to reduction of the throughout improvement with 15%, 20%, and 50%. Now coming to these are about performance benefits and the form of DRAM and SRAM like behavior and its behaviors. And coming to future application and industrial impacts, the total future application is on the AI. Non-blocking DRAM refresh is poisoned to transform the land space of memory access and system performance. This technology has the potential to revolution the industries relying the high performance computing, including artificial intelligence and data analytic, high end of gaming. So the future is dependent on the uh, what is it artificial intelligence. Future applications and industries impact on the artificial intelligence with high performance of computing, including artificial intelligence with the high end of gaming. And also non-blocking DRAM refresh positive transform land space of the system performance with this new technology and the potential evolution relying high performance computing and the intelligence of the data analytic high end gaming. So these are the future applications of the industry impact, how it is it implemented in the industries, and the future application uses interfaces and different types of high performancing including artificial intelligence with the high end of gaming. So it is also a non-blocking DRAM. DRAM means the direct RAM. RAM artificial gradients of membrane that transform the landscape into the memory. The industry's approach with the artificial intelligence and make user-friendly refresh, and it is also a future application and the industry impact morely dependent on this artificial intelligence with the DRAM refresh rate possibles. So these are about the DRAM refresh memory access performances. Thank you.